How's it going, everybody? And in this video, we're going to be walking through how do these liquid crystal displays work on the Arduinos and how can you use your Arduino and program it to display whatever you want on these displays. So this is the setup that I have, and I will post a link to instructions that walk through all this stuff in more details. We're going to go through the theory and walk through the code in this demo just to show you guys how this all works. So basically, your liquid crystal display has 16 pins in total, and in our case we are not going to be using 4 of them because we're going to be only using a 4-bit mode in our case. Because basically, if you look at this liquid crystal display, you're going to have there's basically 16, I'll call these cells, and then there's 2 rows. So there's like 16 columns, 2 rows. And basically what happens each time that your LCD is displaying something is it's figuring out in a given cell, like in the one where the number is changing to number 7 right now, what are the pixels in that given cell that need to be turned on and which pixels need to be turned off. And that is logic that is contained in the liquid crystal.h library that you're including when you're using your Arduino. So basically, when you're wiring all this stuff up, I want to make note that you do include a little potentiometer here, a 10 kilo ohm potentiometer. And if you turn it on and you see issues where it's like really washed out like this, or there's no text at all displaying, you just adjust this thing to make it so that the text becomes visible, just like that, in case you're wondering what's going wrong after you've wired everything up, because that's what I ran into. So do note that you will need to tune this slightly just to get this text to display the way you expect it to. But apart from that, the other key things to make note of on these displays is the following. So we've got a ton of weird numbers and letters, and so VSS, VDD, V0, RS, RW, E, and then D0 through D7, A, and K. So basically the pins that start with D are the data pins, and so these are the actual bits, the ones and zeros that are being written to memory. And so basically the way to think about this LCD display is it's really just a memory chip, and it's projecting the contents of its memory out through light bulbs on all these different little cells. And so when you're wiring this stuff up, I added some comments to the circuit wiring here, but basically 4 of your given wires are all going to go to ground. So you've got your VSS, RW, K pins, and that 10 kilo ohm resistor guy. All these guys go into ground, so it's not as scary as it looks. And the RW pin is what is basically telling the memory chip on the LCD if it should read or write. And in our case, because we're going to be displaying contents from the Arduino to our LCD, we're always going to be in write mode, and that's why we're basically just hard coding our RW pin to be on the ground, just like that on our breadboard. So hopefully this intuition adds some intuition for you guys. Register select the RS pin. That is basically, again, just thinking about your LCD like a little memory chip. You need to tell the LCD which one of all these little cells, because there's 16 by 2, so there's 32 in total, which of these are you wanting to modify, or which ones do you want to read? Because you can read the contents from LCDs on your Arduino, but in our case, we're just displaying stuff, we're just outputting it, so we're always going to be writing. But that is the purpose of the register select pin. And then we've got the E pin, or the EN, or enable pin, and this is allowing us to actually overwrite whatever is there if something isn't there already. And then, as we were saying before, the D0 through D7 pins are all stuff that is bits. So the actual zeros and ones that are what basically is pulling up like a predefined character in memory to show on this guy. So this whole thing, so when you download this code and you make sure you're using that liquidcrystal.h library, this library basically contains a bunch of the super low level stuff that says how to display the character H, or the character exclamation point, or the character 7 on this actual display. It's literally just a picture that is getting lit up here, like a little bitmap image that's getting projected into each one of these things, and that's what makes these things work at the end of the day. And so, when you're creating your liquid crystal object from the liquid crystal class, you are telling it exactly what is that register select pin, what's the enable pin, and then what are the data pins you're going to be using. And because it's only seeing those 4 data pins right here, it's knowing that you're going to be using the 4-bit mode. So it's going to be writing in 4-bit mode, and that will limit the number of characters it has available to it, because that's, you could do the 8-bit mode and start defining your own characters and getting really fancy. But for our cases, you can do most of the damage with just staying in 4-bit mode. And that's how it works. So this is code that I have taken from the Arduino tutorial series right here. So I'm going to basically, all I did was added some comments to make it a little bit clearer in terms of the wiring. But yeah, so this is how it works. And now you can start doing some really cool stuff where you can have your computer disconnected, so you don't really even need a serial monitor anymore. You can plug in just a power cable, and then you can have your Arduino display stuff right here on on the LCD as to stuff like what's the current temperature or position or something like that. So pretty cool stuff that these LCDs are enabling. And yeah, so the only other final thing I want to make note of is, in my case, I tried to make the wiring a little bit simpler. I just took a 220 ohm resistor here, and I went directly from the 5-volt side to the A pin on our actual LCD. So you don't need like an extra wire, because I know there's already a lot of wires here trying to keep it clean, but that is how this thing works. And yeah, so thank you all for watching. And as you can tell, you just play around with this guy. You will need that 10 kilo ohm potentiometer. These things should come in those kits. And so if you have any questions, let me know. Thank you all for watching, and be well.